Hi, we'll do a little detour from the last lesson and we will create the texture sampler next. I'll now create a new region called texture here in the CPP file. And inside it, I will create this new method called createTextureSampler. I will also copy this method and add it in the header file. And we will create this sampler with the Vulkan initialization. So I navigate to the initialize Vulkan method's body and I paste it in here in the bottom. Now, inside the header, we would like to create this texture sampler field of the VK sampler type. And we can go back to implement our create function. We start by creating the sampler info. And we set the S-type's value to the sampler create info. Now the sampler has a set of settings on how to sample the texture. Since the texture will rarely be mapped to the same amount of pixel it contains, we need to specify how will the texture be sampled if it needs to be displayed in a smaller or larger space. After we are done with texturing, I encourage you to test out different settings. You can achieve a more pixelated effect or a smoother effect based on the values that you use here. For magnification and minification, I'll set a linear interpolation. This means that if the space is smaller than the image, it will combine the values of a bunch of pixels and map the mix of those values into the new pixel. If the space is bigger, it will essentially add more pixels in between. That are sort of like a gradient between the pixel colors that we know, but you mostly recognize it as being blurred. The addressing mode of the texture for the UV coordinates will be clumped. This means that if you ever give it a value that is outside of the value 0 to 1 scope, it will just use the 0 as the lowest and 1 as the highest value. Here you might choose to repeat the image so that you can address the -1 UV coordinate and get a mirrored image. There is also a third dimension, but we're not going to care about the W value here, so we set repeat. We will not enable anisotropy. This is a feature that helps some textures appear sharper when scaled. We also set the border color to opaque black. We will not use unnormalized coordinates, so we set it false. This means that we will only use coordinates from 0 to 1. We set the compare enable to false and anything for the compare operation. Compare is used in some advanced scenarios to filter out some pixels by processing them with some comparison functions. We will not use MIP maps as they are out of the scope for now. MIP maps are used in texturing to create prepared sharp image versions of a texture at different sizes, so that it uses the closest size when sampling. I just set some default values to 0. And now we can create our sampler. We pass in the logical device, the sampler info address, no allocator, and texture sampler field. If this operation is not a success, we can exit here and now. And I forgot to put the max anisotropy value here to be 1. Now, the structure we can add this texture sampler destroy call. And while we are here, we can add the destruction of the texture set layout. And the destruction of the texture pool as well, which I forgot in the last video. We can now build and run to validate that all of this works correctly, and it seems to be going fine. We now have a sampler prepared.